7.6 video on sine, cosine, and tangent. Hope you're enjoying your spring break. Don't forget, this is your video you need to watch. So first off, we didn't really have a time to do exploration before we had break. So instead of exploring, I'm just going to explain to you what sine, cosine, and tangent are. So in sine, cosine, and tangent, every time we're talking about right triangles. And these right triangles all have a relationship. A, B, and C with these points, these side links. Now, if you remember from last class when we were talking about the Pythagorean theorem, we talked about the names of the sides. These names still apply. So this would be a leg here and a leg here, and then the hypotenuse here. Okay, so the difference between Pythagorean theorem and sine, cosine, and tangent is basically which sides you're talking about. So the concept that you have to understand here is what's adjacent and what is opposite. When we talk about adjacent, if you remember from earlier in the year, adjacent is the same as saying that they are right next to each other or that they share a common part. Okay, so if I'm talking about two angles being adjacent, they would share a common vertex and side. When we're talking about just the side lengths, this is just talking about one of the legs. So we modify this definition here to be the adjacent, the adjacent leg. So when I say adjacent in this video, I'm saying the adjacent leg. So if I was to say we're looking at angle A here, the adjacent side would be the leg that makes up a part of angle A, which would be this side right here. If I'm talking about angle C, then that means my adjacent leg would be this side of the right triangle. So whenever I say adjacent, I'm talking about the adjacent leg to the angle, not the adjacent side, because that could be the hypotenuse as well. But when we say adjacent, we're actually saying adjacent leg, not adjacent side. Okay, so that would be talking about names of sides. So when we talk about sine, cosine, and tangent themselves, let's first talk about tangent. Tangent is generally the one that's easiest to understand. So when we say the tangent, what we're talking about, the tangent is the tangent ratio. And this is a ratio of the two legs of a right triangle. Okay, now the ratio changes depending upon which angle I choose, angle A or angle C. Now in geometry, we're only going to concern ourselves with either angle A or angle C. We're not going to worry about angle B until you get to trigonometry. So just forget about the 90-degree angle. All we're looking at is angle A and angle C. Okay? So when I say I am taking the tangent of, let's say, either A or C, I'm going to be looking at the two legs of my triangle. Okay? So if I wanted to take the tangent, now When we write tangent, tangent is a long word to write out. So again, I say in class, mathematicians are kind of lazy sometimes. So we like to write things smaller in shorthand. So we say tangent as just T-A-N. Then when we talk about which angle we're talking about, I would say tangent of angle A or tangent of angle C. Now, this makes a difference because the tangent ratio is when we take the opposite leg. That is one thing I forgot to mention in the last video. When I say opposite, or not in the last video, the last slide. When I say opposite, I'm saying the opposite leg. Okay? So if I was at angle A, I'd go to the leg opposite. Going back to our tangent, that would mean I would go from A, I would go opposite, and the other leg would be my ratio. Remember, a ratio is just a division, a comparison of two things. So I would go from opposite over adjacent leg. So when I talk about tangent, I'm talking about the ratio of the two legs of a right triangle. And more specifically, I talk about that in relation to either angle A or angle C. If I'm talking about angle A, my opposite over adjacent leg would be BC over AC. Now, if I'm talking about tangent of C, that's a little different. It's a different angle. So I go from a different location. So if I'm going to do tangent of angle C, I still have to go opposite and adjacent. This ratio does not change. It's always opposite over adjacent legs. But I start from angle C instead. So I'm going to go opposite. So I still do opposite. Here we go. I still do opposite over adjacent. The difference is which side is considered my opposite leg from C. From C, angle C, AB is my opposite leg, and BC is my adjacent leg. So you notice there's two different ratios here, and you'll also notice that the two are just flipped. I did notice that when I wrote AC for tangent of A, it should actually be AB. So the tangent of each of the angles are just reciprocals of one another. So if you know the tangent of one angle, if you take the reciprocal of it, you'll get the tangent of the other. So that's tangent. Don't forget, if you have any questions on this, please ask me a question in the question box in the form. Okay? So our next ratio would be the sine ratio. Again, we have right triangle. Sine is spelled S-I-N-E, and it's pronounced not sin. Okay, it's not sin, it's sine. So again, we still have the same triangle with angles A, B, and C. Sine, however, is the ratio of the opposite leg to the adjacent, or excuse me, to the hypotenuse. It's the ratio of the opposite leg to the hypotenuse. So if I was to talk about, again, we are mathematicians here, so instead of writing sine as S-I-N-E, we abbreviate it as S-I-N. So again, it looks like sin, but it's not. It's sine. Okay? So don't get these two confused. It's still pronounced sine. When we say I'm taking the sine of an angle, let's say I look at sine of angle A. This ratio, as you can tell from the definition, is the opposite and hypotenuse. So I do the opposite leg over the hypotenuse. So if I'm going from angle A, I go opposite leg, which would be BC, over my adjacent, or excuse me, my hypotenuse, which would be AC. Okay? So, sine of A, always going to be opposite leg over the hypotenuse. In this situation, it's BC over AC. If I ask you to find the sine of C, it's still opposite over hypotenuse. The ratio doesn't change. The only thing that does change is which sides you're using. Because I am going from angle C, I'm going to have my opposite leg. So if I start from angle C, my opposite leg is going to be AB. And you'll notice the hypotenuse still stays the same, so this is over AC. Okay? So my sine of A would be BC over AC. My sine of C would be AB over AC. Okay? Really, I should be in the information section because this is what this is. So let's just go ahead and continue from here. So in this section, let's talk about cosine. So we've talked about sine. We've talked about tangent, which the tangent of my angle. When we talk about angles, we use the Greek letter theta. All it is a variable. It represents what the measure of the angle is. So don't get confused with this. So tangent of theta is what again? That's right. It's opposite over adjacent legs. If you said that, you're good job. You're correct. Sine of any angle theta. Here, I'll write this up here, what it's called. Okay, so that's the Greek letter theta. Sine of any angle theta is going to be the opposite leg over the hypotenuse. And the last one is what we call cosine. Okay? So here's our right triangle again. A, B, C. Okay? Now cosine is the ratio of the adjacent leg to the hypotenuse. So that's the only other way I can organize this, right? I've got opposite over adjacent for tangent. And if I take tangent of the other angle, I would have adjacent over opposite, which would be just the reciprocal. If I have sine of angle A, I'd have opposite over hypotenuse, and sine of angle C would be opposite over hypotenuse again, just changing the sides, changing what leg I use. The only other option is adjacent over hypotenuse. And again, cosine's a little long word to write, so we abbreviate it as COS. And it's not cos, it's not COS, it's cosine. That's how you pronounce it. It's always cosine. Okay? So when I say cosine of any angle theta, this is going to be my adjacent over my hypotenuse. Okay? So my adjacent over my hypotenuse. So if I'm looking at the cosine of angle A, I'm going to be going from this angle A, and I go my adjacent leg. So my adjacent leg would be AB, and my hypotenuse is still going to be AC. Okay? It looks like I'm going to be in the way of the dosiri symbol. That's a little better. Let's move this up a little bit more. And the other angle, if I did cosine of angle C, okay, I'm going to go from angle C instead. And again, I go adjacent, so that's going to be BC divided by my hypotenuse, which is still AC. Now, if you notice, one thing you can notice is the cosine of A is actually the same as the sine of C. Sine of C is AB over AC. Cosine of A is AB over AC. So if you know the sine of one, you can find the cosine of the other. Same with cosine of C. Cosine of C is BC over AC, and the sine of A is also BC over AC. So if they give you angle C, and they say find the sine of angle A, you could use the cosine of C to find the sine of A, and vice versa. So that's basically all the different ratios that we have in here, tangent, sine, and cosine. So let's take a look at an example. Okay, so let's say that we've got, let's see, can I type? I don't think I can type. Let's say we have a situation that says, how far up a wall could a 30-foot, actually I'm just going to, 30-foot ladder reach if the ladder makes a 70-degree angle with the ground. Okay, so this, I would imagine you guys would be able to see, is very important when you're doing construction, when you want to hang Christmas tree lights on your house. You're going to want to have a high enough ladder and know what angle to put it at. If you only have just a single step ladder as opposed to an A-frame ladder. So the easiest way to approach these problems, any kind of problem that's a word problem, is to draw a diagram. So since this is the sine, cosine, and tangent video, you're probably going to have a right triangle. So first, let's make a wall. There's my wall. Next, we're going to have the ground. So the ground is brown, so that's on the ground right there. And then I've got a ladder. Now this ladder, and I don't know, you can make it whatever color you want, but I've got the ladder here. We don't know how far up the wall it's going, so I'm going to mark that as my x from here to here. Anytime we don't know a value, we always give it a variable. You can use x, you can use y, you can use w. Let's use y. And I changed my mind to y instead of x. I'm feeling whimsical today. Anyway, the ladder is 30 feet, right? It says it's a 30-foot wall, a 30-foot ladder. How far up a wall could a 30-foot ladder reach? So I'm going to label this as 30 feet. Now the next part says the ladder makes a 70-degree angle with the ground. That means from the ground up until you reach the ladder, measuring up like a protractor, it's 70 degrees. So that means from here to here, that's too dark or too light. From here to here is 70 degrees. Okay? So you'll notice I have a right triangle here. There's my 90-degree angle. The wall and the ground make a 90-degree angle, hopefully, if they constructed it accurately. So we have a 70-degree angle, 30-foot ladder. Now we got to find y. So the question is which do we use, sine, cosine, or tangent? Well, look at what you have. Look at what you've been given. From the 70 degrees, we have y. Which leg is that? That's opposite my angle. So we know I've got opposite. So I've got my opposite leg. Then I also know my hypotenuse is the ladder. So what uses hypotenuse and my leg? My opposite leg? You guessed it, sine. So now all I have to do is set it up in my formula and solve. So the sine of 70 degrees is going to equal my opposite leg, which is y, divided by my hypotenuse, which is 30 feet. Now I'm looking to find what y is. So to get y by itself, my first step, actually I'm going to copy this onto a new slide, so bear with me. So my first step would be to multiply both sides by 30. So that reduces 30 here on the right. So all I'm left with is y equal to 30 times the sine of 70 degrees. Now here's what you need for these problems. You need a calculator. Since you all have iPads, it should not be hard to find a calculator. So what you do is you put in that 70 degrees, make sure your calculator is in degrees. On the calculator you'll see this DEG. If you see that, you know you're in degrees. So you're good to go. So most calculators are kind of awkward. You kind of have to play with them, get used to it. Sometimes the newer calculators will let you put in sine first and then put in the angle. Most of the time though, the older calculators that you can buy in the store, you have to put in the angle measure first and then put in sine. So that's what mine is on my iPhone. If you have an iPhone, or if you use the native calculator for the iPhone or the iPad, that's what you have to do. Put in the angle first and then hit sine. So if I do that, I find that the angle or sine of 70 degrees is about 0.94. Now since this is rounding, I'm rounding up to 100th. I'm going to use a squiggly equal sign, a wavy equal sign. That means approximately. So that means approximately equal. Okay, so anytime you're rounding, you use this symbol here. So now all I have to do is multiply my answer by 30, and I get approximately 28.2 as my answer. This is also rounded to the nearest tenth. So my answer is it'll go about, the ladder will be about, we'll hit the wall about 28.2 feet up the wall. So that's your example. Pretty simple, straightforward. Use these methods that I just showed you on your multiple choice question here. And here's your free response question. Again, the hint is always look to see what you have. Look to see which leg you have and which, if you have it, the hypotenuse. Alright, send me any messages from the videos through the form, and I look forward to seeing you guys on Wednesday when we come back from school. Have a great rest of your break. Bye!